And welcome to Learn Yourself. Today we are going to learn about a gas laws, and this chapter is under ICSE Standard 9 syllabus. Gases and their behavior. We are studying from Standard 6 that they do not have definite shape, definite volume. The molecules of gas always be in the random motion. They are having a maximum intramolecular space and they are facing a least intramolecular attraction. These are the general properties of gas. But why they are behaving so? So let us understand their behavioral properties and their respective reasons. That if they are possessing some properties, then what are the reasons behind them? Let us first understand the diagram of molecules of gas. For example, in this, these are the molecules of gas. They are farly apart from each other. They are having maximum intramolecular space and they are having least intramolecular attraction. So, the first property is they do not have definite shape or volume. You can compress it, you can fill it in any container, and wherever you are filling it, it will expand and it will fill the whole container. So, what is the reason behind them? So, this is the reason that force of attraction is very less in between molecules. So, that's why they do not have definite shape and volume. So, if you will compress it, it will gain your desired shape because they are having very less intramolecular force of attraction. Second property, it shows high compressibility. As we have discussed that volume of particles, it is less compared to intramolecular distance. The volume of particle is very less and the distance is more. If the molecule is bulgy, then the distance will be less. But here the volume of molecule is very less compared to its distance. So you can easily compress them. So this is the reason for that volume of particle is less compared to intramolecular distance. So that's why they are showing high compressibility. Third property, it exerts pressure in all the direction. If you are filling a gas in a cylinder like this, then it exerts pressure in all the direction in the same way. How that can happen? That with high pressure, it generates high velocity. So if you are compressing this, then these molecules will randomly move to each and every direction and they will equally exert pressure in all the faces or all the side of the container equally. Fourth property, they are showing low densities. If we are comparing a three different diagram of solid, liquid and gas, then this will be the diagram for solid molecules, this will be the diagram for liquid molecule, and this will be the diagram for gaseous molecules. You can compare them as they are tightly packed, they are loose and they are having maximum intermolecular space. So they are having low density. So what is the reason behind that? That intermolecular distance is very large. They are having maximum distance and number of molecule per unit volume is less. Now what is the meaning of this? If you will see this, if we are consider this as a per unit volume, then here you can see there are 6 molecules. Here you can see there are 5 molecules and here you can see there are only 3 molecules. So per unit volume, these molecules are less. So that's why they are observing low density. Gaseous atoms per molecules are per unit volume are very less. So that's why they are having low density. So for low density there will be two reasons, that intermolecular distance is very large and the second one is number of molecule per unit volume is less. So that's why the density will be very less for gaseous molecules. Fifth property, diffusibility or miscibility. What is the meaning of diffusibility and miscibility? One gaseous compound will mix with another gaseous compound. It is very easy and it is very speedy. When you are mixing two liquids with each other, if they are miscible, then you have to stir it and you have to make some effort to do it. But for gas, nothing is required. Once you are keeping them together, they will get mixed with each other by their own. So what is the reason behind that? That they are having large space between the molecule. If you will see here, solid is tightly packed. Solid will not allow anyone to come inside because they do not have any space. Liquid, they do have some space, and with some effort, if they are miscible, they will mix with each other because there are some gaps and spaces, so it will mix. And the gases, they are having maximum space between them. So another gaseous compound will come and easily mix up with this compound. So they are having a large space between them and a speedy movement of molecule. We know that they are having only a vibrating movement at their position. Liquids, they are having some movement and they can flow but from top to bottom. But gaseous molecules, they can freely move in any direction in random motion. So this will help the speed of the molecule. The kinetic energy of the gaseous molecule is maximum compared to solid and liquid. So that's why this property will allow them to diffuse or to show miscibility at greater extent. So this can be the two reasons for this, that they are having a large space between them and their molecules are showing a speedy movement, and that's why they are showing a diffusibility. Now let us see behavior of gases by the variable temperature, pressure and volume. These are three basic variables. When we are changing them, it certainly affects the behavior pattern of gases. So let us see one by one. First is temperature. As we are increasing temperature, the kinetic energy will increase. The movement of molecule will increase and the volume certainly increase. With the kinetic energy and with the temperature, the volume will expand. If you are heating a gas container, then volume of the gaseous compound remain inside will increase. So as the temperature increases, the volume of gases will also increase. They are in a direct relationship with temperature to volume. If temperature increases, volume increases, and same way the temperature decreases, volume also decreases. What are the units we are going to use is degree Kelvin and degree Celsius. Now let us see for the pressure. As we are increasing pressure, the volume will decrease. As you are increasing pressure on the gaseous compound, it minimizes its intermolecular space, and that's why the volume will decrease. One will increase, another one will decrease. If you are decreasing of pressure, then volume will increase. They are inversely proportional to each other. One will increase, another one will decrease. And the force exerted will increase. As you are putting more and more pressure, the molecules will move randomly and it will exert pressure on all the wall of the container. So pressure will increase and force exerted on the wall will also increase. What are the units we are going to use? 1 atm. Atm is the short form of atmospheric pressure. So 1 atmospheric pressure we are using, and sometimes we are also using the pressure with the 76 centimeter Hg. Hg is a symbol that we are using a mercuric scale to use to find out a pressure count. So it is 76 centimeter Hg, and this is 760 mm Hg. This is mm and this is centimeter. Both the scale we are using of mercuric scale, and here it is 1 atmospheric pressure. Now let us see for the volume. As the volume increases, pressure will decrease. Certainly, as the container is small and you are expanding it to this, then the what all molecules will be here are having a more space in this. So pressure will decrease as the volume will increase. They are inversely proportional to each other. If volume will decrease, then pressure will increase. So they are inversely proportional to each other. What are the units we are going to use is 1 liter, 1 dm cube and 1 centimeter cube. These are ml, cc, dm and centimeter we are using for a volume scale or volume measurement. So these are the three parameters which will impact on behavior of gas. Two scientists have given their laws based on the behavior property of gases. First is Robert Boyle and second is Charles. So let us first see Robert Boyle's law. As per the Boyle's law, this is the statement of Boyle's law, that when temperature is constant, the volume of given mass of dry gas is inversely proportional to its pressure. We do have three different parameters. We have temperature, pressure and volume. In Boyle's law, we are keeping temperature constant. So we are not checking any kind of effect on temperature because we are keeping temperature constant. Now, he has said that volume of given mass will inversely proportional. The volume will be inversely proportional to the pressure. So this is a statement for Boyle's law, that volume is inversely proportional. Because it's inversely proportional, we have written pressure in the denominator. So it is inversely proportional to its volume. If this is our diagram of gas, then when we are exerting pressure on it, and volume will be decreasing. For that, we are compressing it. So pressure increased and volume decreased. So that's why one is increasing, other one is decreasing. So it is known as inversely proportional. They are having inverse relationship. So if suppose we are releasing the pressure in this situation, so if the pressure is decreased, then volume will be increased. So when one is increased, other one is decreased, one is decreased, other one is increased. So that's why when temperature is constant, the volume of given mass of dry gas is inversely proportional to its pressure. So what can be the equation for Boyle's law? That is P1 V1 P2 V2 equals to K. K when T is constant. So we are keeping only two parameters in our mind, pressure and volume, and we'll check the effect simultaneously when one parameter will increase or decrease. That is all about Boyle's law. Charles law. As per the Charles law, when pressure is constant, in Charles law we are taking pressure constant. The volume of given mass of dry gas is directly proportional to its absolute temperature. Now what is the meaning of absolute temperature? We do have two different scales, that is degree centigrade and Kelvin scale. Now how the Kelvin scale is different from degree centigrade? So when minus 273 degrees centigrade will be there, at that time the Kelvin scale will be 0. The first point of Kelvin scale is all the points, all the temperature is in positive. When we are using this minus 273, it starts from 0. At 0 Kelvin scale, all the molecule movements will stop. It is absolute 0. So as per this concept, absolute 0 temperature, it freezes the water, and even all the molecule movement will stop at this temperature. So that's why it is known as absolute 0 temperature or absolute scale. At 0 degrees centigrade, the water will not freezes. Before it will freezes practically. But as per theory, we learn that at 0 degrees centigrade, water freezes. So this is the difference in theoretical concept and practical concept. So Kelvin scale is different from degree centigrade in this term, that when it is 0, absolute 0, the degree centigrade scale will be minus 273 degree centigrade. So whenever we are checking a movement of gas, we are always using Kelvin scale and not we are using degree centigrade. So back to the Charles law, that when the pressure is constant, the volume of dry gas is directly proportional to its temperature and absolute temperature. So volume is directly proportional to temperature when we are keeping pressure constant. So if we are increasing temperature, the volume will increase. If we are decreasing temperature, the volume also will decrease. So they are in direct relationship with each other. One will increase, the another parameter will also simultaneously increase. As we are studying Boyle's law and Charles' law, there are certain numerical problems based on them. So let us practice some of them. First we have taken a problem based on Boyle's law. So this is the problem that if we are expanding volume of gas from 300 ml to 2700 ml, so this will be our volume 1, that this is our initial volume and we have expanded it to 2700. So this will be our initial volume, so this will be our volume 1. Volume 1 will be 300 ml and this will be our final volume. So this will be V2 and it is 2700 ml. Then final pressure is 1 atmospheric pressure. Here we can see that it has written final. Final means it will be P2. So our P2 will be 1 atmospheric pressure. So they are asking that what was the initial pressure? What was the initial pressure? So we have to find out V1. What is the equation for Boyle's law? It is P1 V1 equals to P2 V2. We do have V1, P2 and V2. We have to find out the P1. What was the initial pressure that we have to find out? So let us put all the detail in our equation. This will be P1, V1. So V1 is 300. What is our P2? P2 is 1. And what is our V2? It is 2700. So here P1 we are keeping here and we are changing the side of 300. So it is going to be 2700 divided by 300. So this is going to be 9 atmospheric pressure. How to write a unit? If you are checking for pressure, then please see that what unit they have given. most probably that unit only will come here. It is very important to mention a unit when you are writing an answer. So whenever you are solving a problem based on Boyle's law, or whenever you are seeing a problem, how to identify whether this is a Boyle's law's problem or Charles' law's problem. So you have to always keep in mind that what all details they have given. They have given the details about volume and pressure. They have not given the detail about temperature, because in Boyle's law temperature is constant. So like this you will get to know that this problem is based on which law. What all detail you are getting, you pile up those detail and then check for which detail they have not given. Sometimes they also mention in starting of the problem that while keeping temperature constant. So immediately you can make out from that statement that this is based on Boyle's law. Let us see one problem based on Charles' law. So this problem says at 39 degrees centigrade temperature, gas X occupies 300 ml volume. If we will increase the temperature till 1040 Kelvin, then how much will it expand? So we do have three information, two temperatures and one volume, and other volume we have to find out. Let us first recall Charles' gas law. According to that law, it says that when we are keeping pressure constant, the volume is directly proportional to temperature. So V is directly proportional to temperature, and when we are writing K, a constant, we will get V by T equals to K. That is our constant. So according to Charles' law, our equation for Charles' law will be V1 T1 equals to V2 T2. So we are assuming that V1 and T1 for first situation when we have not increased the temperature, and this is for when we have increased the temperature, our volume will also expand. This is for first situation, this is for second situation. Or sometimes we will get that initially the temperature, initially the volume. So this is for our initial situation, this is for our final situation. So let us jot down all the information what all we have. So this is earlier situation or initial situation. So I will write this as V1 or T1. So this is 39 degree centigrade. So this will be our T1. That is 39 degree centigrade. Then occupies this much volume. So earlier volume or initial volume is 300 ml. So this will be our T1 and V1. Now for the final situation, they have given only temperature, and that is into Kelvin. So our T2 will be 1040 Kelvin, and they are asking how much it will expand. How much it will expand. Expand means how much it will increase. So they are talking about volume. So earlier it is 300, then how much it will increase at the final stage when we are increasing this much temperature. We have this equation, Charles' law's equation. So let us put all the details what do we have over here. Whenever you are solving this kind of problem, always you have to see whether they have given temperature in degree centigrade or Kelvin. If they have given in degree centigrade, then you have to convert it into a Kelvin. So here if you will see, one temperature they have given in Kelvin, the other one they have given in degree centigrade. So you have to convert this degree centigrade to Kelvin. So how can we do that? Our T1 is 39. When we are doing plus 273, we will get here our temperature in Kelvin. When we are adding 273 into 39, we will get a temperature 312. So let us put all the details in our Charles' Law's equation. It is V1 T1 equals to V2 T2. So what is our V1? It is 300. Our T1 is 312. As we have convert this 39 into Kelvin. Our V2 we have to find out, and the final temperature or T2 will be 1040. So how can we write this? V2 equals to, we will write equation with V2 over left side. So let us shift this 1040 to numerator. This is 1040 divided by 312. So the answer what we will get to after solving this will be 1000, and here it is ml. In V1 they have mentioned ml. So whatever we will get at the end, the answer V2 also will be in ml. So this will be our answer. So when we are raising temperature till 1040 Kelvin, our volume will increase from 300 ml to 1000 ml. So this will be the answer for our problem.